So we are gonna take a complicated trip to an ice cream shop. I mean, because what's better than ice cream than math ice cream? But I wish I had actual ice cream. Maybe as we get closer to the end of the year, I'll bring in anyone here not able to eat like ice cream sandwiches. What?
No, I can bring something to eat. Are you gonna bring a lactate?
We also do like creamsicles.
No,
Popsicles. What are you lactose intolerant?
Yeah. I can just tell me the day and
Oh shit. Well, I like ice cream sandwiches, so maybe I'll pick a day. Alright, so would anybody be interested in reading our intro paragraph here?
Yeah, you can do it.
Dale, you want to practice your theater voice?
Yeah.
Alright, a hush fell upon the crowd. Yeah, one of the biggest.
One of the biggest.
Oh, one of the biggest. Okay. Let's see.
Story time.
Yes, it is story time. Quiet children. One of the biggest challenges in solving problems that involve counting techniques is deciding which method of counting to use. Selecting a counting method depends on whether different arrangements of elements will be considered to be
This is on-site
different outcomes, and on whether elements can be repeated in an outcome. As you work with your team on the ice cream shop problem, starting a list of possibilities will be a useful strategy. The list may be too long to complete, but starting it may help you decide which counting technique to use.
Wonderful. Alright, so I'm going to run to the copier because I forgot to pick up these copies. But go ahead and dive into this problem. We have a hot day. We go to DJ's Gourmet Ice Cream. We got 5 flavors. Check it out, and I will be back in a moment.
So there's 5 flavors left. Blah, blah, blah. Everyone else has 3 scoops. Okay. So 5 flavors, and there's 3 spots. And you're allowed to repeat, right? Yeah.
But everyone orders 3 scoops. The maximum DJ is allowed to ensure
Most people
I got
eat from the top down.
What?
How do you eat an ice cream cone in any other way?
You eat the bottom part and you slurp the rest through the cone.
No, you Jenga it. You have to let it
That's
fall.
what I do.
Jenga.
How do you eat it from the top when there's too much?
No, all you have to do is
Because
take a bite.
3 spots. There's 5 flavors and you're allowed to repeat. Alright.
Yeah, does it make sense that you do like the repeat flavors?
Whoa.
Oh, graphic order, that's gonna help. Okay.
So,
On Friday, does it matter if it's the same flavor?
Wait, is this for a question?
Just today's lesson in general. To be able to organize some notes. 2 ways.
Order does not matter in repetition. It's 100%.
Alright, so what do we have here? Who can paraphrase for me? Abe?
Okay, so DJ's Gourmet Ice Cream Shop has 5 flavors left, and you can order them in an ice cream cone or in a dish, and you can only have 3 scoops. At least on Friday. And then on Saturday, he has 5 flavors with cones and dishes, and you can only have 1 scoop per flavor.
Okay. So we have a couple different situations, right? Did you check this out yet? So here's what we're actually trying to do. Here's our objective. We have 4 different counting problems actually here. 2 in Friday, 2 in Saturday. Notice there are 4 boxes on the back organizer. So, what different formulas can you dig up to talk about each situation? So take a moment, try to figure that out. We know a couple of things, like when order matters, like what NCR was and what NPR. We talked about those things.
No.
going to slide this up because I need to pull actually, I think I'm working on another page. I need to actually move away from this.
Everything. Oh my god. You're nice. Just like you.
That's the repetition part.
Okay.
Order matters and order does not matter. We are trying to figure out how to find
repetition matters on Friday. The repetition is Saturday. I know, that's what I'm saying.
There's two different ones. Remember, there's two different repetition, no repetition matters.
more than 100.
Order does not matter in a dish, but does in a cup.
Yes.
Okay. Figured it out now.
So,
The best is
You can get 3 scoops in a day.
you can get 3 scoops on a cup.
Order does not matter in a day.
so if you stack from top down, so that's going to be the order. So there's order and dishes.
Order matters is from stuff doesn't matter.
Order matters with
Yeah,
the
but
code.
you don't
It does not matter with the code.
Wait a minute.
Allows no more than 1 scoop of particular liquor per customer. So there's no repetition for both of them.
No, there's no repetition for Saturday. So there's repetition for Friday.
Well, yeah, but right now we're working on Saturday. We're reading Saturday.
Friday is no repetition and
Ice cream sandwich.
All right, did we figure out when does order matter, when does it not?
Order matters in a cone.
In a cone, right? So if we are going to talk about how we formalize these, like in the formula.
Technically, order matters in a dish because then you don't want one that's like in the middle or like
That's
You
not
can
an order.
eat them in any order
It's about
based
eating.
off like access. You're not going to eat your middle scoop first.
That'd be
unless
cool
you're
if
trying
someone
to,
does. They're Jenga. That's what I was saying earlier.
Yeah.
Jenga. Just fall down and see.
That sounds like a terrible idea.
But then it'd be like, wow, you're really
Okay.
cool. Okay, let's continue. Sorry.
I was trying to think of that. But
Please don't.
all right, so when order matters, but you're allowed repetition. Let's say we have n items.
It's in a cone on Friday.
What? It's in
That's the two boxes.
On Friday,
The repetition is Friday.
on Friday, people just yeah.
and then what else do we need to know? We have n items, and we
Have 3 spots.
yeah we can choose
So
R.
And
5 and 30. 5
NPR. So
So what would it be for our ice cream?
5.
5.
And then
5 CR. 5.
And what turns it if we're doing a combination or a.
It's a combination because order doesn't matter.
Well, in this one it doesn't matter.
Well, I know this one.
Yeah, it depends. Which one are you trying to have a solve for?
The
Like,
one that doesn't matter.
This
The one
doesn't
that
use a C or a P.
what?
This doesn't use a C or a P.
Oh,
It's
it's just 5.
repetition.
Because repetition.
125.
Well, I figured out it was supposed to
How do I
be
operate with N and R? What
N to
math
the R.
should I do?
N
N to the R. When order matters and repetition is allowed, first slot, 5 choices. Second slot, 5 choices. Third slot, 5 choices. Right, 5 to the third power. You can decision chart that if you want. But the problem is this would be like R amount of, you know what I mean? Because this would keep going depending on R. And then N and N and N and N. All right.
There's not 4.
Well, I know, but this is our amount. So that's the danger of making a decision chart here. Now for ice cream, we know it's 5 to the third. but we're talking general. We want to create our general formulas and have this as kind of like a cheat sheet. What about when you're not allowed repetition and order matters? What is this box talking about then? Yeah, it's a permutation, right? So with n items, choosing R, it's going to be n p r. How did we calculate that?
N factorial over n minus r factorial.
Yes, n factorial over the difference.
The quantity n minus r
When we are allowed repetition.
That one is a I was gonna say union for some reason, combination because
Combination, but order. But
it doesn't matter. Order doesn't matter.
yeah, but also the general.
So if repetition is allowed, is that a combination?
No. It's something different. But.
Hey guys, unless we're rapping about math, I think it'd be more beneficial to engage in this conversation. So wait, what did we talked about combinations yesterday? What makes a combination?
Just like a mix of.
Order doesn't matter, but you can't repeat.
Like, give me an example of a combination. Yeah. So, but like real life, like clothes,
okay.
right? Like what outfit you pick out,
People
or
in
yeah, people in a committee as opposed to people on like a ranked panel. So order doesn't matter, and no repetition, right? I can't wear the same shirt twice. So the combination is here. And then this, when order does not matter and repetition is allowed, it's unique to the situation. We got to analyze as we approach it.
Wait, no, I don't think. I think. So you guys said that one says enter was 10.
What?
I didn't do the formal math. So if we come back to our problem. No.
I got 5.
Where am I? Well, it's slightly off.
That's with 3 choices. 3 scoops.
So here we go. Here we go. So we'll solve these. I just wanted to get the formulas onto your guys' cheat sheet. So let's talk individual situations now, which I think you guys have been talking the whole time. But some customers order their ice cream in cones. Let's talk about Friday first. Cones versus dishes. Cones, order matters. Is repetition allowed? Yeah. You can be boring if you want. You can repeat. So this becomes, 5 to the third, 125. If you get a dish, I don't know why you would do that, because you get more with the cone. Well, maybe not more ice cream. You get
the cone.
Cone is superior.
It is superior.
In my humble opinion. So what is this? How do we do it? Or did you just make the calculator do it?
I know how to do it.
Well,
5 factorial over.
Yeah, order doesn't matter.
Never mind. I
So
went
wait,
over
what?
the wrong box.
No. Because I can eat them in any order.
So Friday, you're allowed.
Wouldn't you just add 5 more combinations?
There wouldn't be more. If we're talking a dish where the order is irrelevant,
Yeah.
that's like yesterday when we talked about CBA being the same thing as ABC.
Okay, can't you just do the NCR plus 5? So it'll be 5 more combinations because you can repeat flavors. Oh no, because then there's the 2, 2, 1, and then 1, 1, and then the thing.
This is overcounting, right? We got to deal with the amount of overcount.
What was the combination formula?
For each flavor, there are.
Oh, we probably should have done that.
I'm about like, you know how like NPR was like n factorial over n minus r factorial.
Well, it's that.
Yeah, so this we
That
should
one, like,
worth
what's
thinking of. The actual formula here, what did we write down yesterday for NCR?
Over the same thing, but like you added and
Yeah, it's the messy part.
Wow, that's exactly where my smart board's broken. Sorry, this is n minus r
it's not
factorial
it's just you add r factorial.
times r factorial
Wait, and what are
n minus r. Sorry, this is
Oh, that.
Yeah, like.
my board like jumped
I thought
there.
you were talking about the formula. I was like,
That
that's
one.
not that.
That was like a formula.
Because we had that crazy division, we used the giant one,
Yeah, so then
right, to get that into the denominator. So our n factorial, what is our n here? 5. So we got 5 times 4 times 3 times 2. And then divide by, what would this be? 2 factorial times another 2 factorial.
2 times 4
Or,
factorial. 2 times
So-
6 is what?
Oh, I got it.
sorry, yeah,
Yeah, so
the r factorial is 3 factorial.
Why is it 3 factorial?
Because r, the number of like slots.
would you add? So you have to add the. So you have to add 6 per flavor because there's the chocolate. So if you do all the one, it's all the same flavor. So that's an extra 1, and then you can do 2 scoops of one flavor and 1 scoop. We'd have to add 5 more per flavor.
5.
Scoops.
Yeah, so 5 over 2 factorial.
Wait, but then-
I'm sorry. They're looking at getting interactive monitors as opposed to smart boards. So I'm really hoping that I'd be near the top of that list.
You
My
can draw
board
on your
is
monitor.
it's like touchscreen. But
So like, and then you cancel out the 3 and 5, so it'd be 2 factorial over 2 factorial.
So
Wait,
what?
no, I'm wrong. That'd be 4. That'd be
5 factorial.
4 times 5 over 2 factorial.
Yeah. What? 20 divided by 2.
Which is
5
10.
over 12.
is this right?
So 4 times 5 over 2 factorial is what you're saying? Yes.
Yeah, because once you cancel out the 3 and the 5, then you have the 4 and 5 left over.
Yeah.
If
But
you get
the
rid of the
combination, you can't repeat. But this one you
I
can.
mean, that's correct for the combination. I thought, okay.
This one we can repeat,
For combinations, we doing this would be correct because we're
Yeah, that's
but this would allow repetition.
Yeah, so that's why it's wrong.
Yeah, this isn't right here.
Well,
This
maybe
would-
we
it
wouldn't
wouldn't
keep that there
allow-
and see if we can do anything to help, maybe.
Well, I can rewrite that somewhere where it doesn't look so sloppy.
Okay.
So if we're allowed repetition, the order's irrelevant. How did we approach that yesterday? 2 days ago, or whenever it was that we talked about that. We did those overcounted. So we know how many options there are, right? 125.
Yeah.
But what do we do to deal with the overcounting? So when we take the ice cream out of the counter, now order doesn't matter. So chocolate, strawberry, vanilla, or whatever, I forget what the flavors in this problem are, is the same as vanilla, strawberry, chocolate, strawberry, vanilla.
Would we divide it by
Any
divide it by 5 because there's 5 main flavors?
Only 5?
Would you divide it by 5 because those are the 5 things that you overcounted for each of them? Should they be
That's just for that. That would be the. That would.
I'm thinking that you would divide it by 5 because there's 5 main flavors, so like you're overcounting for each flavor because you counted each of the different combinations of like the flavor
Yeah, I
of
think
one
there's
flavor.
5 extra when you repeat. That's what I'm saying.
Okay. Yay.
That makes sense.
What?
No, what you're saying is correct. This says it should be 35, but I think it should be 25.
Okay. Yay.
Yay.
So that's one of the weird ones, the one where we said like analyze the unique situation. So if we go ahead and look at Saturday.
Oh my gosh.
High five and sad. Jenny, no.
Saturday, what's different?
No repetition.
No repetitions. So now we're on that right column on our cheat sheet.
Oh, because there's more. It's hotter outside, so there's more people coming in, so he just wants to.
Yeah, they want to keep
We don't
balanced
need to worry
flavors.
about our ice cream information.
So what is this? In a cone, yeah. In a cone is 5. Permutate, choose 3, and that's 60. And then in a dish, 5 combine 3.
That's easier.
So
Number was like weird off the reach.
is DJ's advertisement correct?
That they have.
He lied. Why?
Because there's only a total of 70 choices, not 100.
On Saturday, there's only 70 choices. When I can double stack favors,
On first.
On
On Friday, there's
One
only
25.
On Friday, it's just 9. But
On
On
Saturday.
Friday, there's like.
Oh yeah, because you had to do the extra. Sorry.
like,
It's a good thought for him to have.
kind of recognized.
all right, ready to move on.
Yes.
Let's do. We can skip to 12:45 actually. Charlie and Jake. Oh, this is even better.
Oh,
Charlie and
wow.
Jake go to the snack bar, and they are just so excited. They're salivating. They're. Those are very standard, like.
Yeah, but like,
American
why
names.
can't they do anything creative?
Oh, come on. Okay, so Charlie promised he'll buy Jake 3 snacks. Okay, right, like brothers, cousins, something like that.
Bottomless hunger pit.
Yeah, so as they're arriving, Jake tries to convince his uncle to buy all of the snacks at once rather than spread it out over the day.
Diabetes.
No, not like everything on the board, but like let's just go ahead and buy all 3 so we don't have to come back to the snacks thing.
Yeah, still.
Okay, you guys are so judgmental.
Oh, you guys are
Calm it down before high school.
We've been through this
Those
endurance.
two
We
are gonna
know
be like,
So,
oh, super heavy,
here we go.
super skinny.
How many options up here? 7 things to order, right?
Jake has a dilemma.
Jake, of course, has a dilemma because math can never be easy. He likes everything on the menu and says, you know what, I'd be happy with anything. Or even any 2 of the same thing. Or even any 3 of the same thing. I like them all so much, I'll even eat 3 of the same thing. Right? Now, Charlie thinks variety is good, so he wants Jake to choose 3 different things.
Because what if it's like he likes, no, because he could be like, I'll give you 3 of the cheapest thing ever. That's what a good uncle move is. Get this where they like, but if it's cheap, it's also perfect.
So, your task, with your team, list all possible options for Jake and Charlie to consider. Well, you don't necessarily.
Would it be 5?
You just write the answer.
Oh, and would it be 3 keep 7 or?
Oh, sorry. So, when that says options, we mean like the 4 grid of like, what if I allow repetition? What
Oh,
if
okay.
Yeah, so we're not doing repetition because the uncle says.
Well, I think, are we going to do both of their scenarios, like what Jake wants or what his uncle wants?
Yeah, so compare Jake and Charlie. So if Jake gets his whole, I'm going to order 3 of anything and repeating's allowed, versus if Charlie gets a 7.
Oh my god. I have to make a parody order. So you know that one song that like I was rapping earlier? So I need to make a parody and it has to be like, no repetition. No repetition.
Stop.
blah 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 blah. And I'm gonna make a rap, and it's gonna be like on the top of
I
the
feel that at the end of the year ceremony, we're gonna be so
And then
proud of you.
teachers will be pulling it up in their classes to show their students and help them with
I'm
it.
gonna be like.
I will say, there's some interesting math to be done here, but to help you set up your 4 situations, yes, but, so check it out. When you eat them, because it's not like the ice cream, you're going to eat them all at the same time. When you eat them, can matter, right? Like, oh, first I'm going to have my popcorn, then I'm going to have my corn dog, and then, well, I should have eaten my snow cone first, but now I'm going to drink this sugar water. So here's your 4 ways. Charlie gets his way, and there's order and no repetition. Charlie gets his way on timing only, so order with repetition, right? Order matters, but he can eat the same thing twice or 3 times or whatever. Then Charlie gets his way on variety only, so no order, no repetition. And then the Jake gets what he wants. Now the Jake gets what he wants is more complicated than what you think about it.
Jake, no order. That's the order and repetition.
That's the order doesn't matter.
Well,
That's the order.
That's the unique one.
Yeah, order doesn't matter.
Wait,
no,
there's no repetition.
there's the 4 different ways is what we're looking at.
What's the last one? Didn't we divide the order matters with repetition by the number of options?
It's unique to the situation. So what you're dealing with in the 1 quadrant of that table is unique to what's going on in the problem.
So
You don't
it's a
know.
different operation.
So no, like we can use some of the same stuff. Like one of these we'll use NCR, one we'll use
Well,
NP.
yeah, but like that kind of stuff.
Mr. Hudson,
No order.
why does order matter?
Because they're going to spread out through the day. So we're not
No,
eating
but
all
they're
the
all
snacks.
They said they're buying it all right now.
I know,
No.
but like I know it's weird, but thinking of I'm going to eat snow cone, corn dog, cotton candy is different than eat cotton candy, corn dog, and snow cone because my snow cone's going to melt.
That's dumb.
I know. Just look at this mathematically. Quit trying to make sense of it.
They're ordering it all at the same time, but in the order that they're going to eat it.
We're very judgmental.
You're going to have it all.
Oh, actually, I think the big thing is that, okay, Charlie doesn't want to buy them all at the same time. So not only are they going to space out when they eat them, but when they purchase. So sorry, that's the big thing about order mattering is Charlie's actually going to purchase 3 different times. Which would make sense because if you want to eat your snow cone last as your afternoon snack, don't buy it now. So Charlie might have a point.
Just eat it before it melts. That's how you eat food.
You want to
He
eat it
wants
when
to have
it's
it
warmer in the day.
Well, he's just a picky child.
Yes.
Yeah, exactly. That's the point.
Success.
No success.
Do you want to debrief it?
Boy, boy,
Oh,
success,
sure.
though.
Give another minute or actually give another few for people to work.
That's what I already told you.
Should I just do the order and
I like your little table that you made. Like the repeat, no repeat, and order, no order. I bet I could just put a square right here and make it white.
So you can repeat,
So give us somewhere to
and
write.
the order doesn't matter. So that's just information.
No, it's not.
No, it's not
It's unique to the situation. So we did the previous one. We divided it by redivided the total, like the total focus value where it is repetition.
What we're doing by the options.
The number of options. So 343 divided by
It's
7. Wait, no.
Okay.
Yeah.
Are
Okay.
we done?
I think so. I think I did it.
Got it or
We.
solid it?
We did it.
What if we just dang it? Oh.
Put my fire on.
Thank you. You don't need it.
You know what? I
They're
don't-
nice using it.
All right. I'd love to give you guys a little bit of time to work on your homework. So let's have Ava debrief. You can obviously keep working if you're still working, but she's gonna set up her work. It's glorious.
Let's
It's
see if we
wonderful.
did it right.
We did.
It is.
Okay.
It's all perfect.
Okay.
It's old.
Let's see what you got.
It's old.
What is M stand?
Matters. Order, so matters.
Ah.
And it does not
So, to avoid using an O, which is tricky with math because it looks like a zero,
I just didn't know what
Ava has now said matters for order matters. Now you could have also just said like OM, like
Yeah,
order matters,
but,
or like or on
Okay.
ON.
So these three are basically exactly the same as
on
the other problem. Yeah.
Hey, click. This will make your life easier. Click right there, like tap right there, then change your thickness to the top one. Yeah, that'll make your writing smaller so that you can fit more.
So this one is 343. 210. This one is 85.
85.
Or 30, 35 and 30. I can't remember.
I was gonna say like
That's the 3 and that's the 5.
You guys would never
I don't
let me
think
get away
that's
with
a
that.
We're still not letting you.
No.
Ava, I don't think that's a
We're
5.
silently judging her.
Oh.
You're not silent.
That number is
I'm not
three,
silently
and that
talking.
number
That there. Okay. That's there. Okay. And then for this last
The
one.
weird one.
Yeah, the weird one. So I took 35 because that's the
Whoa.
without repetition that doesn't include like all three of the same flavor. And then I took the 7 different like snacks that there are, and for each snack there's 7 more combinations that can happen. So, like corn dog, or corn dog, popcorn. So like there's 7 more, and then so you square 7 and it's 49. And then it's 84.
Plus.
What? We did 343 and then divided it by 7.
Okay, you can do that too. That's what I did.
We got 49.
Interesting.
wait,
That's
no repetition.
interesting.
Is that repetition? Isn't that covering both no repetition and repetition because it can have repetition but it can also not have repetition.
What?
So you don't want to add the 35 then, right?
No, you add the 35 is because it's that's how many combinations of 3 different things there are. So like popcorn, cotton candy, and root beer.
The combination
So
of
there are 35 different combinations, but then there's also the repetition. So you add the 49.
Because what we did was look at the last problem where there was 125 like choices and then we divided by 5 to get 25.
Well, in this situation,
Right.
it's
Wait,
7 objects
okay.
instead of 5.
Still the
So
same
I
concept.
might know where they got their 35 from. These
Oh,
We didn't
situations
get
are really
35, we
weird.
got 49.
And
We got 49 for
So
the
her 84 is right. So to
I
put
was
that out.
afraid.
Now this I was used to Pearson having a decent amount of typos. I don't think I can ever really think CPM has typos because they've been published for a while. Teachers would have caught it, and that's why they keep reprinting these books every year. They're not books, they're binders. If we step back here for a moment, I think after looking at a new situation, I know exactly how they got their 35. So we up here took,
So they did get the right answer. It was 35, not 25. So I didn't-
yeah, but we need to look at why. So when how did we get our 25? We took,
We divided it by 5, which is the total different like flavors.
so this was the N to the R, and then we divided it by the N, right? Sorry, so that was 5. This was what? What does that 25 represent?
It represented like whether it's a lot of repetition, but order doesn't matter. So that was representing. I think it was the first plate of ice cream.
Why do we divide by the 5?
Because there's so many different spaces.
Those were the different flavors, so I
So we get rid of the overcounting, but then why did you add your two numbers together?
Because adding.
Your 35 and your 49, why?
Because adding the repetition to the combination.
So this is the repetitions, because we got rid of order mattering, but that's only the repetitions. We also want to add in the combinations.
So we add the number of. So we add that number with the number of still no repetition.
Because what is a combination?
A combination is just like
Well, like where on your table does it fall?
it fits under no repetition or doesn't matter.
So no repetition, order doesn't matter. This is the repetitions, right? So if we add 10 to here, then
so
this
we would add
covers.
10 was the combination.
This
10.
covers with repetition and the ones that don't.
Okay.
That's
So we got it
why.
partially right.
So I think we could have made that jump, and like I'll own this too. I think we could have made that jump if we had looked at this before really dealing with the unique situation. Because this is just the repetitions, doesn't do enough. Like we took away too many. We got to add back in. Now, if you want to see the really complicated way that you can think about.
How'd you get your 49? Because we got
Well, okay,
49.
so there are seven different snacks, and each snack, if you like factor in repetition, has 7 more combinations that can occur, because you have the one combination that's just the same thing 3 times, and then there are 6 other snacks that pair with the thing if you have it 2 times.
Okay. I'm just gonna roll out.
I'm not sure. Is that correct?
You're making sense. It's just hard to follow somebody else's explanation if it's not how you're thinking.
Yeah.
So if you decision chart this, like it said, writing them out can start to help you think about it. Guys, if you can't figure out these problems, make a decision chart, because that is actually to help you decide what type of problem it is. So we can have, like we did yesterday, corn dog, and if that's going to happen twice, how many other options are there? Like if I'm not going to do corn dog 3 times? 6, right? If I do corn dog all 3 times, that is just one more option. And then if I do corn dog just once, then I have 6 and potentially 5 or 6, depending on if you've already looked at other pairs. So if we start to list out the different combinations here, and I think they made all the first letters unique potentially. Well, no, the C gets used a bunch, but you can do dogs, candy, apples.
Dogs, candy.
Okay. Okay.
Candy apple dogs.
Oh, ew.
Gross.
I had to.
I have to. So, in
It might be
this
easier to eat than candy.
unique situation. So, again, Ava, what was your 35? Actually, hold on. Because you guys got the 49, what was your 49?
Our 49 was divided.
343 divided by.
I'm saying what we were dividing the repetition order matters by the amount of different options, which is 7, because it's like corn dog.
Yeah.
Example.
So your permutations,
Yeah.
No.
or well,
Not a
Not a
permutation.
permutation.
with. Sorry, I'm trying to
Well,
explain it
permutation
too
divided by
complicated.
another, not permutation. Factorial divided by factorial.
Yeah, it's.
Specific.
Let's not try to explain it that way. I went down that road and then realized it was bad.
Yeah.
So you take your end of the R, which is the easiest one to do, right? When order matters and we can have the same thing in every spot. That's the first thing that we ever thought about, like blocker combinations, things like that, where you can repeat numbers. Then divide by how many you have in the situation. That gives us only part of what we're looking at, though.
Other.
Because then this, where's your 35 come from, Ava?
That comes from the combination.
Is the combinations. Combination, you cannot repeat anything. Right? Questions? That's why there's so few also. The other thing that we should recognize with this table is how we go down as we go left to right, top down. Because we have the most options when we can repeat and order matter. Because that makes a lot of things. Then as you take away things that matter,
Cool.
you get less and less options.
Yeah.
Because when more things matter, you have more options.
Okay, so are we done with the list?
Yeah, I mean, we only have like 2 minutes left, and since she has a question about
Who has
homework.
4 Russian tags?
Why do they have so many?
Oh, that's your question.
Yes. Because you can only put them on his bookshelf in one way, but there are so many different texts and like has it.
These are
They're just
different
overthinking.
textbooks. So that's like, why do I have so many math books over there?
Because you're math.
But you
It's
can
not
only-
like they're all the same German book. It's like 4 different or 7 different books in German.
Okay, how do you
Language and math is different.
I
Math is a
understand.
language.
Ooh.
Yeah, but this is many
Ooh.
languages, not just one language.
You're right,
Math
that's why
is
he's
a
got so
language.
many.
That's only one language. That's why I say that that's a lot.
But every branch of math is kind of like its own language.
Okay, so it's
Like
one
algebra versus
That is
geometry
1, 2,
versus
3, 4,
calculus.
5 languages versus
How do you
8
solve
languages.
it?
Oh, how do you solve it?
That was my question.
Would you do 3 times 7 times 2 and so on and so on because that's how many different options are for each.
So if it's alphabetical order,
There's only one way to from a bookshelf.
Or Russian text.
Well,
7,
there's
11,
multiple ways because
12,
they're doing it because they're not the exact same book. So like,
Yeah, but there's only one arrangement.
let's talk about this stuff.
what you just do?
If you can't figure it out, that's fine.
Wouldn't
But
you
I would
just-
rather you guys think about it
Ava,
than
look
just
at
give it
this.
to you.
If your order matters and there is repetition, that would be the language of the book. And
There
if you
isn't
are,
a repetition because you can't have 2 Danish books.
there's 3 Danish books.
Yeah, but not on his bookshelf.
Yeah, he's putting them all. In
No,
alphabet.
he's not.
It's alphabetical by language. So your first section has to be the Danish
So
books.
it's not by like this book.
Your next
He's
section
bringing one book of each language, though,
No.
to his classroom.
I know, but it's a book from the Danish. It's in order, not by like book title or anything else. It's in order by language.
Yeah.
So you know your first slot has to be a book that is Danish. So what you're really saying is how many options are there.
So
Then your next slot,
I was
has to
doing
be
right.
a German
7.
book. Then your next, I think Italian is next alphabetically. I would
German
assume
is
they did
not.
it right. Then
And then
Okay.
Italian and
Yeah, we're
Japanese.
not-
then
Has to be
Japanese,
answered.
Russian.
yeah, like I said.
All right, get out of here, guys. Have a great day.